Hello students, welcome back to CLARIconcepts, Unleashing Conceptual Learning. Today in this lecture, we are going to solve several numerical examples based on fluid velocity and acceleration. So this is really important topic as far as fluid kinematics is concerned, and understanding of this topic is really essential. So those of you who have not yet gone through my previous lecture where I have explained you what is velocity and what is acceleration and how is acceleration dependent on different velocity components. Please go through that lecture first and then come back over here. Okay. So today in this lecture we are going to solve several numericals on this topic. Let us start with the first numerical. So let's say if I just give you the brief of what is velocity acceleration, I said that if I have a fluid flowing through the circular pipe, let's say, and if I just denote this particular pipe through some reference frame, and if I have a particular point in the pipe which is referred by a position called x, y and z. So in this case velocity is referred as, velocity v is referred as ui plus vj plus wk, okay, where u, v, w are the components of x, y, z and t. So I can say that u, v and w, all of these three are variables of x, y, z, that is space coordinate as well as time, okay. And if I talk about acceleration, so this is vector quantity velocity. Acceleration has three components again, axi plus ayj and plus azk. And we have seen that all of these three components have a long equations to remember, but I have given a shortcut how to just denote the equation. You see, shortcut is over here, ax, ay and az. If you see, each one of them has several elements, right? Four terms. Each of them has four terms corresponding to x, y, z and t. So firstly, if I denote term for time differential for time, then I said for x, then v del by del y, and then for z, w del by del z. And these four terms will be common in all the three expressions, that is ax, ay, az. So we will put as it is. This is very easy to remember, so I am showing it to you. In exams, you do not make any mistakes. Now see, since it is ax, basically it is dealing with the x component of acceleration. So all the x component of velocity, which is u, will be there at all the place, right? Similarly, this is ay, so it is dealing with the acceleration component of y-axis. So velocity of y component, that is v, will be there, and here w will be there. So now I hope remembering the equation for acceleration is no more difficulty for you. Okay, so let us now go on to the first example. Given a velocity field v equals to 4 plus xy plus 2ti plus 6x 3j plus 3t square plus zk, find the velocity magnitude of a fluid particle located at this particular point and at this time. See, velocity field is given to you. So if I just write down the velocity field, so let's say I will go for solution. So v is given to me as 4 plus xy plus 2ti plus 6x cube j plus 3xt square zk. Now if you compare it with the conventional equation that v is equals to ui plus vj plus wk, you can see that this is your u, this is your v and this is your w. So you have been asked to find out velocities at a point 2, 4, minus 4, that is x is 2, y is 4, z is minus 4, and at a time t equals to 3. So what you do, you simply put these values in these equations in this particular places. So I would say that velocity component, so let me now just take component wise first. So I will take u. What is u from this equation? U is 4 plus xy plus 2t. Now finding out u for the component like this. So I can say that u at a point 2, 4, minus 4 and time t equals to 3, I will get. So I will put 2 in place of x, 4 in place of y, minus 4 in place of z and 3 in place of t. So I will put 4 plus x is 2, y is 4 plus 2 into 3. What is the answer? 4 and just use the calculator if you want. 8 plus 6 plus 4, simple, it is 18. 18 units. So this is U at this point. Now what is V at a point 2, 4, minus 4 and t equals to 3? Just substitute the value of, V is as such 6x cube. So at this point, if you want the V, what you can get is, at this point V will be, let's say this is point P, I'll just simply write this is point P. So V at a point P can be said as equal to 6 into what is x value? X value is 2. So what is the answer? 2 cube, that is 8 into 6, 48. 48 units. And then W is what? W by the velocity profile, it is given to you as three x t square plus z. So 3 into x is your 2, time is your 3, so 3 square, and z is your minus 4. So you do calculation, 3 into 2 into 3 square is 9 and minus 4. You will get 50 units. So now you got all the three components, u, v and w. So you can see that velocity v at a point 2, 4, minus 4 and t equals to 3 is equals to, what is u? U is 18 units. So this is 18i plus what is v? It is 48 units, 48j plus what is w? It is 50 units, 50k. So in coordinate system you can write it like this, 18, 48, 50. So this is the velocity vector at this particular point given a flow field at this particular time. Now they have asked us to find out the magnitude. How do you get magnitude? Simple. You take the magnitude of velocity. Magnitude of any vector can be found by taking square root and then square root of the addition of the squares of individual components. So 18 square plus 48 square plus 50 square. Look at what is the answer, 18 square plus 48 square plus 50 square, 5128, and under root of that will give me 71.6 units. Okay, whatever are the units, it is 76.1, 71.6 units. This is the answer. So the magnitude of velocity at a given point and at a given time is this answer. Clear? Let me check the answer. I think answer is correct. Okay. So I hope you understood how to solve this numerical. Let us take another example for better clarity. Given a velocity field, so you have been given the velocity field. Find out the acceleration of the fluid particle located at the same point. So see, this is the same example, but now they are asking us to find the acceleration at the given point and time. So for finding out the acceleration, first you need to know is axi plus ayj plus az. Okay. So you need to know what is ax, ay and az, and once you know this ax, ay, az in terms of this space coordinate x, y, z and time coordinate t, and then you can substitute the values of this point and time into that to get the value of acceleration. So let us first figure out what is this ax, ay, az. So we know that by definition ax, ay and az, I'll put the formulas. This will be del by del t. See, I'm helping you to remember this formula. U del by del x plus v del by del y plus w del by del z. Similarly, you'll put over here the same stuff all the three times. U del by del x plus v del by del y plus w del by del z, and over here del by del t plus u del by del x plus v del by del y and plus w del by del z, and you put over here u everywhere because it is x component of acceleration. You put here v and you put here w. You got the equation. Now in order to get all these values, you first need to know what is u, v, w. Okay, let me start with the x first. See, I know what is u. U is equals to 4 plus xy plus 2t. Okay, what is v? V is equals to 6x cube. And what is w? W is 3x t square plus z. Now I will start with ax. Ax is equals to del u by del t. That means differentiation of u with respect to t. So differentiating this with respect to t, keeping all the other variables as constant, this is partial differential. I hope you know how to do partial differential. In partial differential, the variable with which you are differentiating, you have to take that only into account, and rest all the variables can be considered as constant. So when you derivate this, that is del u by del t, when you derivate this with respect to time, this will be 0, this will be 0, only 2 will remain. So for first term it is 2, then plus, this is u, so I will put u as it is, that is 4 plus xy plus 2t. Now, I have this question, del u by del x. So differentiation of this with respect to x, 4 is 0, differentiation of this y is constant, x is 1, so will just give me y, and then differentiation of 2t with respect to x is equal to 0. Then, this term, v plus, what is v? 6x cube is the v. Now, what do I want? Del u by del y. Differentiation of this u with respect to y, this will go to 0. Differentiation of this with respect to y will just give you x. Differentiation of this will give you 0 with respect to y. Then plus w del u by del z. Plus w is 3x t square plus z. What is del u by del z? Differentiation of this with respect to z. What do you get? This is 0, this is 0, there is no z term involved, so this will be 0. So the entire term will go to 0. So what you will remain with is ax is equals to 2 plus 4 plus xy plus 2t into y plus 6x raised to 4. Okay. Now, let us find the value of ax at this given, because now once you found ax, you need to find the value of ax at this point and this time. And then find out ay, then find out the value of ay at this point and this time, and similar for az. So let us find out ax at a given point. So value of ax at a given point is 2 plus 4 plus x into y. What is x? X is 2, y is 4. So you can say 2 into 4 plus 2 into time is your 3. And that y, what is value of y? It is 4 plus 6 x raised to 4, 2 raised to 4. So get this answer first. It is 2 into, so let me solve this first. 4 plus 4 2s are 8 plus 6 into 4 plus 2 plus 6 into 2 raised to 4. You will get 170 units. Okay, keep this in mind. Now you will go for ay. For ay, firstly I need to use this formula, right? What is del v by del t? Differentiation of this v with respect to t, 0. There is no term t. Then plus u into this, plus what is u? U is this value 4 plus xy plus 2t into what? Del v by del x. Differentiation of this term with respect to x, what you will get? X cube, so it will be 3x square, 3 into 6, 18x square, plus v del v by del y, plus v is 6x cube. What is del v by del y? Differentiation of this with respect to y, 0. There is no y term. Then plus w del v by del z. So plus w is what? 3x t square plus z. And then differentiation of this with respect to z, it is 0. So both of this term will go to 0. So what you will left with is ay equals to 4 plus xy plus 2t into 18x square. So we will take the values of this also at this point in time finally, but before that I will find out the formula for az. Let us talk about az. Del w by del t, differentiation of this with respect to t, what is the answer? 3x t square, so 3x is constant, t square differentiation will be 2t. So 3x into 2t will be 3 to the 6 x t. okay, plus u del w by del x. What is u? 4 plus xy plus 2t. 4 plus xy plus 2t. Okay. Then del w by del x. What is del w by del x? First term is 3 and x differentiation is 1. So 3t square. And differentiation of z with respect to x will go to 0. Right. Now plus v del w by del y. Plus v is 6x cube. Del w by del y. So do you think there is any y term over here? Differentiation of this with respect to y is 0 and this is also 0. So this is 0. Plus w, that is 3x t square plus z into derivative of w with respect to z. Differentiation of w with respect to z, that means this is 0 and differentiation of z with respect to z is 1. So just 1. So this is the final form of az. Now once you got ay, once you got az, let me now finally find out the value of ay and az. First let me calculate take it to the next value. Ay is what? Ay is equals to what I have found? 4 plus xy plus 2t. 4 plus xy plus 2t into 18x square. If I am not wrong, let me check. 18x square. Okay. Now, I know the values of 2, 4, minus 4 and time equals to 3. So, I will put the values. 4. What is value of x? That is 2. Value of y is 4 into 4 plus 2 into time is 3. And that into 18 into x is 2. 2 square. What is the answer? Let me check. 4 plus 8 plus 6 into 18 into 4. You will get 1296 as the answer for ay. Now what is az? Let me check back the equation. Az is 6xt. It is 6xt plus 4 plus xy plus 2t plus 4 plus xy plus 2t 3t square into 3t square plus this is directly 0 3xt square plus z plus 3xt square plus z. Okay. Now put the values over here again in this equation. You will get 6. What is x? X equals to 2, time equals to 3 plus 4 plus 2 into 4 plus 2 into 3, okay, into 3 and then time is 3 square plus 3 into x is 2 and then time is 3 square plus z is equals to minus 4. So directly I will put minus 4. So find out the answer for this. First of all, I will solve this one. So it is 4 plus 6 into 3, I think I will take it cube, and then plus 6 into 2 into 3, this term, and then plus I will take 6 into 3 square 9 and then minus 4. You will get 464 units. So you got AX, AY and AZ. Okay, and AX is in the previous question that you have got somewhere over here, this one. So the question was to find the acceleration of the fluid particle. So therefore you have got the acceleration. How? You say that the acceleration of fluid particle A is equals to AXI plus AYJ plus AZK, which is equals to AX is 170 units, it is 170I plus 1296 J plus 464K. This is the answer. And if you want the what do you say answer? If you want the magnitude of this acceleration, you can easily calculate the square root of all these 3 values. You can get the answer, right? Let me check whether it is correct or not. 170, 1296 and then 572. I think I made some mistake. This should be 572. Let me check. The expression is 6xt del u by del t, del w by del t, it is 6xt, okay. Then u del w by del x, u is as it is, del w by del x is, you will get 3t square, okay. And then plus del w by del y is 0, del w by del z, you will get only 1, so w is 3x square, xt square. This is, I think, correct. Let me just check whether I have wrongly substituted the values or not. 4xy 2t, 3t square, okay. 6xt, okay. So let me check the values. X is 2, t is 3, x is 2, y is 4, t is 3, t is 3, x is 2, t is 3. Let me just calculate it once again. 4 plus 4 to the 8 plus 6 into 3t square. So 3 into 3 into 3, then plus 6 to the 12 and then 3 plus, I would say 3 into 2 into 3 into 3, okay, and then minus 4, this is coming to 572, this is wrong, calculation mistake was there, 572 units, right. So we can put this as 572, this is 572, all right. And finally, if you just calculate, if you want the magnitude of A, what you can do is under root of all these 3 square, that means under root of 170 square plus 1296 square plus 572 square and find the answer. So square plus 1296 square plus 170 square, under root of that you will get 1426.77 units. Let me check, 14, perfect, this is correct. So I hope you understood how to solve this equation for, solve these numericals for acceleration, right? So in example 3, what we have is, velocity field is given by this particular equation, which is steady, incompressible and two-dimensional field, where x and y coordinates are in meters and the magnitude of the velocity is in meter per second, okay. So velocity field is given to you and it is said that the velocity field is steady, incompressible and two-dimensional flow, and where the coordinates x and y are in meters and velocity v you will get in meter per second. Determine the location of a stagnation point in a flow domain if there is any. So they are asking us to determine the location of stagnation point. Stagnation point is defined as a point in a flow field where the velocity of the fluid is 0. Now see, they have also given definition of stagnation point, to whom they are referring to as stagnation point. So they are saying that the point in a flow domain where velocity is 0. When I say velocity is 0, that means both the components u and v should be 0, right. So let us first see what is u and what is v. So firstly we will see at what points u is equals to 0, and then we will see what points v is equals to 0 in the domain, and if at all there is any common point coming out, then we can definitely say that at that particular point both of them are 0. So first we will equate u to 0 and then v to 0. So when I say u to 0, u, what is u? U is this value, right? So I can say 0.5 plus 0.8x is equals to 0. That means what is x? X is equals to minus 0.5 divided by 0.8, and you will get x as a, just a minute, 0.5 by 0.8, you will get minus 0.625 meters. So at all the points where x is equals to minus 0.625 meters, you will have u is equals to 0. Then we will see at what all points v will be 0. So v will be 0, I will equate the value of equation of v, the formula of v, that is 1.5 minus 0.8, y to be equal to 0. So what is y? Y is equals to 1.5 divided by 0.8, and therefore y is equals to 1.875 meters. So what does this mean? At all the points in the flow domain where y is equals to 1.875, the v is equals to 0. So there is only one point where both of them are 0. So at all the points where x is this, u is 0. At all the points where y is this, v is 0. There will be dedicatedly one point when x comma y is equals to minus 0.625 meters, comma 1.87, y is 1.875 meters. So in entire flow domain, there is only a single point where x and y coordinate belongs to this, where the velocities, the entire velocity field is 0, 0. So this is the stagnation point, and this is the answer. Clear? So I hope you understood how to solve numericals pertaining to velocity and acceleration. For more such videos, you can log into our website clariconcepts.com. Thank you. See you in the next class.